Okay, I'm going to be shorter than that. Yeah. Well, thank you for all the people here tonight. I know it's it's 5:45, Friday night. We had a couple of presentations ago. Some words about Hennessy cocktails. So everybody's heading to the bar. So yeah, thank you for being here with me tonight. In particular, after all these great conversations, we're talking now about infrastructure. My name is Fabrice Moizan. I'm a Chief Revenue Officer at Gcore. Just give you little words about my background. 10 years ago, my company was acquired by NVIDIA. I became Vice President of Cloud in Europe. I launched the cloud activity, GPUs in the cloud, essentially for cloud gaming. It was in 2013. That was a time where people were laughing at NVIDIA, thinking of GPUs in the cloud. What a stupid idea. What are you going to do with GPUs in the cloud? Well, now you know where NVIDIA is. I left NVIDIA a few years later. I moved to the US, built with some friends an AI chip company. We got acquired later on. I moved back to Europe, and now I'm part of an interesting venture, which is make AI available to everyone, everywhere, anytime in the world. So, who's Gcore? My company. I mean, we a European company. We're based in Luxembourg. 10 years ago, Gcore was created as the back end of a gaming company. I don't know if there are any gamers in the room. You may have heard of World of Tanks. World of Tanks is one of the top 2 largest independent gaming companies, and this is a multiplayer game that people use on the web. Latency is important because when you play games, you put money on the table to play your game efficiency. If you are in São Paulo, if you are in London, if you are in Paris or Tokyo, and you play multiplayer game, you don't want to lose your battle. By the way, World of Tanks is people playing, fighting during the First World War on all tanks. So you don't want to lose your game, right? So latency, you press a button, you want to hit the target. So latency, it's been key. Second thing is security. You don't want your game to be hacked, and hacking is the playfield for the best hackers, right? They all want to make money from game companies or just take advantage of what gaming can provide. So what Gcore did, and Gcore was the IT entity initially of wargaming. They built a cluster, an array of 180 points of presence around the world. So servers sitting in small data centers around the planet. Then all the players who wanted to play could play it very efficiently, low latency, in a secure mode. And all these POPs were efficiently connected together. So after that, well, Gcore moved to instead of serving one customer, became serving and served other gaming companies and banks and retail companies. And today, be honest, we have one larger customer, which is TikTok. Today, what we call the CDN, content delivery networks we built for TikTok, is quite powerful in over 120 countries. It allows, when we are using TikTok and you want to look at the video, you don't have millions of videos stored near you, right? It's all, we call it caching, efficient caching. So our network allows TikTok to be accessed quite efficiently. So that's what we built. And now we think the next big revolution is to access AI globally in a very efficient way, in a low latency way, and a very secured way. We're in the world of AI. I mean, it's been here today. We talked about the future of AI. It's a big business, right? Gen AI, ChatGPT changed everything. NVIDIA became, when I was at NVIDIA was a 500 million revenues company and worth a couple of $1 billion. So you know today it's worth $3 trillion and revenues of 30 billion per quarter. And well, NVIDIA was doing well over the last few years, but Gen AI all of a sudden changed everything. And what we see today, most of the revenues coming from NVIDIA is for training, to train essentially the large language models, large LLMs, and some of the Gen AI models. But OpenAI, of course, is NVIDIA's largest customer through Microsoft. You have Anthropic through AWS and other companies. And of course, so proud and so lucky to have the largest, one of the largest in the world and the largest language model here in France, Mistral. Mistral, what they do, they train their model. They make their model become very efficient by feeding it with lots of large data sets. And that's why, I'm not sure it's Mistral, but we heard today that Nebius, for instance, partnering with Equinix to build a very large 150 megawatts data center here in Paris. You know, 150 megawatts means probably over 100,000 GPUs. So you need 100,000 GPUs to train very efficiently a model. This is what we call training. The next thing is inference. Inference is the application. Think of OpenAI. GPT is the model, the AI model that was built to become an application. Once the model is 90+% efficient, you can make sure you can build a good application. What is a good application is ChatGPT. ChatGPT is what we call inference. That's when you put your model in production. I use ChatGPT, let's say maybe 20 times a day for a lot of things. And of course, you all use ChatGPT. Everybody today has been using ChatGPT and the rest. ChatGPT doesn't require much of latency, right? This is, yeah, you can ask questions, you can do summary of your day-to-day activities, plan a trip, whatever. Use it as your personal assistant or even psychologic. But you can wait for a few seconds. The future, the real future, is the new set of applications we're going to see coming soon. And well, many of them, you heard of Elon Musk talking about humanoid robots recently. He's saying that there's going to be on the planet after 2030 over 1 billion humanoid robots built. He's going to send them to Mars to test the ability for people to live there before sending the real humans. But he's going to put them in his factories as quickly as possible. Human robots, type of robots, they can't tolerate latency. They can't tolerate being hacked. And this is the new kind of applications you're going to see soon at what we call the edge. Inference at the edge. It's like my game. It's like the World of Tank games. You can't, if you have any action from these robots, you can't wait seconds. You can't even make it milliseconds, right? And this is the future of inference and edge. Instead of, you're going to have still the large language model or LLM or Gen AI model, multi text, image, video model being trained in a very large data centers using hundreds of thousands GPUs. But then once the application, the robotics applications come to the edge, well, it's a new game plan, right? It's, as I said, latency, it's security, it's also sovereignty. This is clear that moving forward, all these applications will not tolerate to be run from a large data center sitting away from you for many reasons, right? Moving back and forth a large amount of data takes time, costs money, takes latency, and also security. I mean, one of the reasons why we have those large data centers built in France is because we want the data to be secured, right? We want healthcare, government, human personal data to be secured. Automotive, of course, self-driving cars. Waymo already launched officially, commercially, their self-driving car service in San Francisco. More's going to come. I was in Saudi recently. You have this large project, Nemo, where they're going to send a bunch of vehicles, helicopters around Nemo, moving fast. Well, AI agent, the next big thing. TikTok was telling me that this is the thing for the future. You're going to have a virtual person telling you how to deal with, how to buy things, how to behave. And this is all about low latency human avatar, and keep the data secure in the closed environment. While we do Gcore, well, we train data. By the way, we have 2,000 GPUs that we use today. We one of the largest park of GPUs in Europe, in Luxembourg, in Finland. We have some in Korea. So we allow people to train their models and then deploy. We have an application, for instance, in Korea, where one of the largest car manufacturers in the world have decided to integrate some LLMs, language models, in their autonomous vehicles, AV vehicles. So they train the model in Korea, and then the next day, they deploy the model globally in each car in the world, and they use Gcore's infrastructure. Oops. So what we've built, Gcore, is not only hardware. Everybody's talking hardware, but what is very, very powerful is the software. That's why NVIDIA is so successful. Many companies trying to build chips, but NVIDIA have built the software, and we can connect everyone in the world thanks to the 10 years of building this infrastructure for the gaming. We have today 180 POPs around the world. That's why I told you. That's why it's efficient, and that's why we're going to be, it's so different than, it's an example. My friends from OVH, they have, they have a presence in France. They build data centers. We don't build data centers, but probably have 20 POPs around the world. We have 180, and that's what people want to deploy the application globally. So that's Gcore. Thank you for your time. Thank you for staying here. Enjoy the cocktail, and see you soon. Merci.
Thank you so much. Thank you so much. Thanks so much. That is, ladies and gentlemen, guess what? Believe it or not, I'm sure you will believe it. It's the end of our day